Welcome to the Bodhi Academy. My name is Amisha Kulaso, and in today's video we will continue with our chapter Square and Square Roots. So previously in this chapter we learned the different square numbers and their square roots value. Then further we also understood how we can make out without solving the actual square root, just by looking at the numbers in the units place, if we can figure out if they have a perfect square root or not. So in today's class we will learn about this numbers between square numbers. So we will try to get a pattern regarding this. So firstly we have 1, so 1 square. Second we have the 2 square. So now 2 square gives us 4. So now the difference between 1 and 4 is that there are two numbers over there, that is 2 and 3, that are not perfect squares. Then after 4 we have 9, that is the square root of 3 square. So then here we get 4 numbers that are in between missing, which do not have this square roots. If we go down, then we next have 16, that is square root of 4 square, where we have this 6 numbers. And lastly if we look at 25, that is the square root of 5 squares, then in that case we get 8 numbers. So now if we look carefully at this pattern, the difference between the consecutive this square root numbers is that it is a multiple of 2. So from 1 to 4 we are missing out on 2 numbers. Then from 4 to 9 we are missing out on 4 numbers. 9 to 16 we are missing out on 6 numbers, and 16 to 25 we are missing out on 8 numbers, and this trend will continue so on. So what we can say here is that in general we can say that there are 2n non-perfect square numbers between the squares of the numbers n and n plus 1. So let's understand this. So what we are saying is that when we have a number n and we have n plus 1, the number of non-perfect squares between these two are 2n. Let's take an example over from here this itself. So say we have n as 4, okay, and we have 4 plus 1 over here, so that will be 4 and 5. So here we have this 4 square, this is 4 square will be 25. Now if I have to find the numbers missing between these two numbers, what I can do is simply do 2 into n. So n here is 2 into n will be 4, so that will be 8. So from 16 if I count, so we have 16, 17, 18, 19, 20, 21, 22, 23 and 24. So we are having perfectly 8 non-perfect square numbers. So that we could easily calculate using this formula 2n. So now let's check for n equals to 5 and n equals to 6. So let's continue. First take n equals to 5. If n equals to 5, then the next number would be n plus 1, that would be 5 plus 1, that is 6. So now we have to find the non-perfect square numbers that exist between these two numbers. So say now so we directly do 2n. So 2 into n is say 5, so then it gets 10. So 5, if I take square of 5 and square of 6, so this will be 25 and 36. So from 25 till 36, so 26, 27, 28, 29 and 30, then 31, 32, 33, 34 and 35. So perfectly we are getting 10 non-perfect square numbers that are present between 5 square and 6 square. So this way next we can even do for n equals to 6. So now if n equals to 6, then n plus 1 will be equal to 7. 6 plus 1, that will be 7. So here 6 plus 1. Now find the square roots of them. So 6 square will be 36 and 7 square will be 42. So if you have to find out the numbers in between them, 2n. So 2 into 6. 6 2s are 12. So if I go from simply let's do this and we get minus 36. So this will give us 8 over here. Yeah. So this. So we can find out in this way also. Okay. Next, let's look what happens when we add any two odd numbers. So here what we have done is that the first, so we have odd numbers starting from 1, 3, 5, 7, 9, 11, 13. These all are odd numbers. So what we have done here is that first odd number is 1. So 1 square. Second odd number mean the first two odd numbers. If I have to write natural numbers starting from 1, I'll write it as 1, 2, 3, 4, 5, 6, 7, 8 and 9. So in that my odd numbers are 1, 3, 5, 7 and 9. So 1 is my first odd number, 3 is my second odd number, 5 is my third odd number, fourth odd number is 7 and 9 is the fifth odd number. So in this case what we are doing is that we are adding 1 plus the second odd number, that is 3. So 1 plus 3 gives us 4 and 4 we get by the perfect square root, that is 2 square. Similar way, if we go on doing from 1 plus 3 plus 5 we get 9, that is also a perfect square. Then 1 plus 3 plus 5 plus 7 also gives us a perfect square. So if you see that the adding of the odd numbers gives us a perfect square number. So what we can say is that the sum of first and odd natural numbers is n square. So whatever we are adding over here, the answer of that would be n square. So now see, we'll try to verify this. So say I have 25, okay. Now if I see here above, I have got 25 by adding 1, 3, 5, 7 and 9. So now we'll try and subtract this in the reverse order. So 25 minus 1 I'll do first. So I'll get 24. Then 24 minus 2 I'll get 22. Then I'll do, this is odd number, so 23. Here we'll take 3 over here. So I'll get 21 here. Then 21 minus the next odd number is 5. So I'll get 19. Then 19 minus the next odd number, that is 7. So in that case I'll get so in this, if we go on doing, see, 25 minus 1 we get a 4, then 24 minus 3, that is there, we get 21, 21 minus 5 we get 16, 16 minus 7 gives us 9 and 9 minus 9 gives us 0. So what we notice here is that if we go successively subtracting all the odd numbers from this perfect square number that we have, we end up on 0. Now if we do the same for a non-perfect square number, okay, so if I say take 38 in this case, so now if I do the reverse trend, that is subtracting the odd numbers from the given number 38, what I see is that eventually I am getting the decrease that we see. But what happens here at last is that we don't end up with a 0. We get a negative integer over here. Whereas this wasn't the case when we were doing it for perfect square numbers. So this is one thing. So what we can say here is that, so we can say that if a natural number cannot be expressed as a sum of successive odd natural numbers starting with 1, then it is not a perfect square. So if we cannot get a perfect sum of all the successive and odd natural numbers starting from 1, then we won't get a perfect square in that case. So in this case, this was 16. Then we did and then okay. Now let's look at the sum of consecutive natural numbers. So say I have 3 square that is equal to 9. Now if I have to add any two numbers to get 9, it would be 4 plus 5. Now if I see the trend here, 4 plus 5, how am I getting these two numbers? So 4 plus 5 can be obtained if I take 3 square minus 1 divided by 2. In this case I'll get 3 square will be 9 minus 1 upon 2, and here I'll get 8 upon 2, that is 4. Similarly, now if I add one number to it, so I'll get 9 plus 1 upon 2, so that is 10 upon 2, which is 5. So in this way I can get the two consecutive natural numbers that I can add and get the perfect square number. Now let's look at an example. Say I have 5 square, that is 25 equals to 12 plus 13. Now this 12 plus 13, say now I have to get 12. So first I take this 5 square and I subtract 1 from it and then divide it by 2. In this case I'll get 25 minus 1 upon 2, that is 24 upon 2, which is 12. So I get 12. Next I have 13. So this I can find out how, 5 square plus 1 upon 2. So that is 25 plus 1 upon 2 equals to 26 upon 2, that is 30. So that is how I can find the sum of consecutive natural numbers which are perfect squares. Now let's look what happens when we have product of two consecutive even or odd natural numbers. So we have, say, two odd numbers that we are multiplying, that is 11 into 13. Now 11 into 13 gives us 143. So 143 is not a perfect square number, not a perfect square number. Okay, but what we can do here is that if I subtract, like if I take 43 minus 1, I get, sorry, if I take 143, minus 1, I get 142. So in that case, if I see 142, I can have a perfect square. That is, if I take 12 into 12, that would be plus 2 and 1. So I get 144. In this case, sorry, it is addition here. So I get 144 here. So what I can say is that if I have 12 square, that is 144, and I minus 1 from it, I get 143. Now in this case, 11 into 13 will be equal to 12 minus 1 into 12 plus 1. So that is, if I have to get 11, one way is I subtract 1 from it, and then the next odd number that I am taking is 13. So that is adding 1 to 12. So therefore I get 13. So similarly, if I take 13 into 15, so 13 how can I get? Simply adding, subtracting 1 from 14, and then if I have 15, then I do 14 plus 1. So in this ways we can get the product of two consecutive even or odd natural numbers. So what we can say here is that we can derive a general formula saying that a plus 1, like how we took 12 plus 1, 14 plus 1, 30 plus 1, 45 plus 1. So adding one number and then multiplying it with a minus 1 gives us a square minus 1. That is the perfect square number that we get. So if we have to take this example, say I have here 14 plus 1 and 14 minus 1 equals to, this will be 15 into 13. 15 into 13. 5 3s are 15. 3 1s are 3, 4. Plus 195. 195. So 195 minus 1, 194. Okay. So in today's video we learned the numbers between the square numbers. Then we saw what happens on adding odd numbers. Then we saw the sum of consecutive natural numbers and also the product of consecutive even and odd natural numbers. So that was it for today's video. Please don't forget to like, share and subscribe to the Bodhi Academy.